So today we're diving into something truly incredible, a visitor from another star system, an object named 3I/Atlas. And let me tell you, it's big, it's fast, and it is putting on an absolutely spectacular show for scientists right now. You know, our solar system can feel like this quiet, isolated neighborhood. But every once in a while, a traveler from a completely different galactic cul-de-sac just wanders in, and it's carrying the secrets of its alien origins. This latest one, it's a real head-turner. Okay, so let's properly introduce our main character, 3I/Atlas. Now, this isn't just some rock from our own backyard. Oh no, this thing was born in the swirling disk of gas and dust around another star, countless light years away, and it's been drifting through the void for millions, maybe billions of years. And that number, that's the key right there. 3. 3 Atlas is only the third confirmed interstellar object we have ever detected. Think about that. Before 2017, we hadn't seen a single one. Now we're on our third. Yeah, you might remember its predecessors. First, we had that bizarre cigar-shaped mystery rock, Oumuamua. Then came 2I Borisov, which, looked a lot more like a comet we'd recognize. And now we have 3I Atlas, which in so many ways is turning out to be the most exciting of the three. So what's the big deal with this one? Well, it's because it's so much larger and brighter than the others. That makes it way easier for us to track and study. It's like an archaeologist being handed a perfectly preserved giant artifact from a civilization they never even knew existed. It's a gold mine. But here's where it gets really cool. This visitor didn't just show up quietly. As it gets deeper into our solar system and closer to the sun, it started to change. Astrophotographers have captured these stunning images of its coma, that's the gassy cloud around its core, and it's glowing with this distinct, vibrant green light. And right there, that's the question that has totally electrified the entire astronomical community. It's turned what was already an exciting observation into a completely captivating mystery. And the answer, as it turns out, lies with our very own sun. So how in the world do we crack this cosmic code? Well, it isn't magic. It's chemistry. It's this beautiful, dynamic process playing out on a celestial scale as a piece of an alien world reacts to our star for the very first time. Okay, so think of this comet as a giant, dirty snowball that's been in a deep, deep freeze for eons. As it gets close to the sun, that intense solar radiation acts like a blowtorch. The ice doesn't melt, it turns directly into gas, and this process releases all this trapped dust and organic material. Then, the sunlight literally shatters these complex molecules, creating a very specific, very unstable little molecule that is the key to this whole thing. And the main culprit here is a molecule called dicarbon, or C2. It's super simple, just two carbon atoms stuck together. When this little guy gets blasted by the sun's ultraviolet radiation, it gets all energized and excited. And to calm back down, it has to release that extra energy as light. And what color light does it release? You guessed it, green. Now, this instability is also why you only see that brilliant green color in the head of the comet, the coma. See, the C2 molecule is actually really fragile. The very same solar radiation that makes it glow also destroys it really, really quickly. So by the time all that material gets pushed back to form the comet's tail, the dicarbon is gone. It's been broken apart into single carbon atoms. But look, this glow is so much more than just a pretty light show. It's a profound clue. Seeing this familiar chemical signature, this green glow, on an object from a totally different star system, well, that's a massive hint that the chemistry of comets might actually be universal. It tells us that maybe, just maybe, we have more in common with that distant, unknown star system than we ever could have imagined. It suggests that the basic ingredients for making planets, and maybe even for life itself, aren't some kind of cosmic fluke unique to our little corner of the galaxy. And it gets even better. Scientists are also looking for another molecule called cyanogen. Now, if they find that, it would mean the comet contains not just carbon-carbon bonds, but also carbon-nitrogen bonds. And those are the very bonds that are absolutely essential for amino acids. The building blocks of proteins and life as we know it. As you can imagine, this potential discovery has sparked this massive, coordinated effort around the world. It is a frantic race against time to capture every last drop of information from this fleeting visitor, because once an object like this is spotted, the clock starts ticking. Immediately. Alerts go out to observatories everywhere. You've got some teams taking these incredibly high-resolution images to study its shape and structure. Others are doing what's called photometry to measure how its brightness changes. But the number one priority for everyone is getting that definitive chemical fingerprint through spectroscopy. Basically, spectroscopy is like forensic science on a cosmic scale. By taking the comet's faint light and splitting it into a rainbow, a spectrum, astronomers can see this unique barcode of bright and dark lines. Every single molecule has its own distinct pattern, allowing scientists to say with certainty exactly what the comet's coma is made of. And the stakes here could not be higher. You see, 3I/Atlas is on what they call a hyperbolic trajectory. In plain English, that means our sun's gravity isn't strong enough to trap it in an orbit. It's going to swing by once and then get flung right back out into deep space, never to return. This is our one and only chance to study it. Which of course leaves us with this final mind-bending thought. This little green comet is a tangible piece of evidence that the raw materials for life might not be rare at all. They might be delivered all across the galaxy by these cosmic travelers. Now, that doesn't mean life itself is common, but it certainly suggests the potential for it could be, well, everywhere. And that is a truly awesome prospect to think about.